In this video, we'll be discussing addition of vectors. A vector has both magnitude and direction. Applying 10 pounds of force at 30 degrees can be represented by the vector 1030 as shown below. A vector can also be designated using rectangular coordinates. The horizontal component is the x value, and the vertical component is the y value. So our polar form of our vector, 10 pounds of force applied at 30 degrees, can be shown this way. And then if we break that down into its horizontal and vertical components, we can see that the vertical component would be 5, and the horizontal component would be 5 root 3. So the rectangular form is shown with the x component first, and then the y. We can also find the x and the y by taking the magnitude of the vector and multiplying it by the cosine of 30 to get our x component, or the horizontal component. And we can take the magnitude 10 multiplied by the sine of 30 to get the vertical component, or the y value. Now, if two or more forces are applied to an object, we can find the resultant force by adding the vectors together. To do this, we need to change each vector to rectangular form, and then add the horizontal components together and add the vertical components together. So let's find the resultant force of 4 at 20 degrees added to 7 at a negative 230 degrees. We first need to change these to rectangular. So we will do our x values first. The x value for this vector is going to be 4 times the cosine of 20. And then we're going to add to that the horizontal component for this vector, which would be 7 times the cosine of negative 230. So 4 cosine 20 plus 7 cosine negative 230 gives us a horizontal component for the resultant of negative 0.7407. Now I'm just going to write the rounded number here, but I'm going to store this value. We do that by hitting store, and then I'll store it in memory A, so I'll press enter. And I'm going to make a note here that I put that value in my A memory. The vertical component we would find by finding the y values for each of these and adding them together. So the vertical component for this vector is 4 times the sine of 20 degrees And then I'm going to add that to the vertical component for this vector, which is 7 times the sine of negative 230. For sine 20 added to 7 sine negative 230. And it looks like 6.7304. Now I'm going to store that value. So I'll press store, and I'll put that in memory B. And make a note here. So our resultant is going to be a negative 0.7407 I plus 6.7304 J. Now usually when you talk about the resultant force, you want to talk about the vector with a magnitude and a direction. And these are the horizontal and the vertical components. So we want to change to polar to get the magnitude and direction. Of the resultant. We'll do that with our formulas. The magnitude R is found by the square root of our x component squared plus our y component squared. And our direction theta is found by arctan of y over x. Now this was my x value, and this was my y value. So for my problem, my r is going to be the square root of parentheses negative 0.7407 squared plus 6.7304 squared square root of, and I had my x component in memory A, so I'm going to recall A, and I can do that with second recall. So second recall, and then I'll get that here. Now I want to, it's hard to see because you have so many numbers here, but if we move back to the beginning of our problem in the calculator, this parentheses opens the radicand, and I need to insert another parentheses because when I square a negative, I want that answer to be positive, and it won't be unless I put that in parentheses. So I'm going to insert another open parentheses to go around my A value. Close my parentheses and then square that value, plus, and then open my parentheses and recall the B value, which is my Y, second recall, B, press enter, and then I want to close that up, square that value, and then close my radicand. So my magnitude of my resultant vector is about 6.77. My direction will be inverse tangent of y, which is 6.7304, divided by the x, which is a negative 0.7407. So for second tangent, I need second tangent, and then the numerator is my y value, which I stored in B. So I'm going to recall B, divided by, recall A, because A is my x value. So I'm getting, on my initial calculations, a theta that's about negative 83.7 degrees. Now the calculator will only give us values in quadrants 1 and 4 because the domain of arctangent is restricted to those two quadrants. So I need to make sure, first of all, that I have the correct angle, and then also usually you give the direction as a positive angle, so I need to do that as well. So let's just look at my resultant. The x value, or the horizontal component, is negative. So left, and the vertical component is positive. So our resultant should be up here in quadrant 2. This angle is in quadrant 4. Since the angle that my calculator gave me is in quadrant 4, I'm going to need to add 180 degrees to get it into the second quadrant where it needs to be. So I now have 96 degrees and 28.28. So my resultant vector has a magnitude of 6.77 and a direction of 96.28 degrees. When we're talking about vectors, we sometimes want to talk about a force that will balance a resultant, and this is called the equilibrant. So the equilibrant is the force needed to balance or negate the resultant. So for our vector, this was the resultant. The equilibrant is the one that goes in the opposite direction. So our red vector that we got initially here would be the equilibrant, or the vector that would balance this resultant. So we can write our equilibrant would be 6.77 at negative 83.7. And again, usually when you talk about vectors, you don't use a negative angle. So to change this negative angle to a positive angle, let me get that back. There it is. To change this negative 83.7 to a positive angle, we can just add 360. So our equilibrant is 6.77 at 276.28.